Okay, Assalamualaikum. For chapter 1, it is the introduction of the regression analysis. So actually, this topic, uh, you dah a little bit familiar in diploma level. So for this subject, kita akan cover lagi introduction of the regression analysis a little bit before we go further in other chapter. Okay, so walaupun ianya revision, but akan adalah dalam your assessment nanti. Okay, so what is regression? Regression analysis is a statistical technique used to utilize the relationship between the two or more quantitative variable so that the dependent variable, which is y, can be predicted. Okay, can be predicted from independent variable x. So usually we will use the regression analysis untuk tengok relationship di antara two or more quantitative, okay, quantitative variable. So before we proceed with the regression analysis, you need to know, you need to determine whether your variable is quantitative or qualitative. Kalau your variable is quantitative, barulah you boleh proceed with regression analysis. So what is the quantitative variable? You already know, you are very familiar with these types of variable. So untuk regression, usually first of all, before we proceed dengan analysis, you need also to determine the variable, whether that variable is your dependent or independent. Whether your dependent, biasanya kita akan notationnya sebagai y and independent sebagai x. Okay, other names of dependent adalah response variable dan juga other name for independent variable adalah explanatory variable. Okay, so the linear regression show the linear relationship between a dependent variable and independent variable. Tadi I'll talk about the regression. So regression ni it can be polynomial, it can be linear, and it can be quadratic regression. So in this topic, kita first chapter ni kita fokus dulu kepada linear regression. So linear regression will show the linear relationship. So macam mana kita nak tengok linear relationship between the dependent and independent variable, between your y and x? First of all, you need to we can draw the scatter diagram, and from that we can see the pattern, whether it is linear or ada curve, right? So itu that is the first method nak tengok whether our data is linear or not. Another one, we also can use the test of the dipanggil correlation test to see whether our data ataupun our variable are significant, have the significant linear relationship between the two quantitative variables. Okay, and then we also will have the multiple linear regression models, which is we can see the relationship between more than one regressor variable. Means that we will have more than one independent variable. So from there, we can build ataupun create the multiple linear regression model after some of the assumption are satisfied. Okay, so essentially, regression analysis attempt to measure the degree of correlation between y and x. Degree of correlation means that we can know whether the relationship, walaupun dia ada relationship, whether that relationship is strong relationship ataupun moderate ataupun weak relationship. So from there we can see that the relationship between the two variable ni strong ataupun tidak. Okay, so for this part, macam mana kita nak tengok whether the relationship is strong or not? We can see you can calculate the correlation, which is the R. So actually the correlation ataupun the relationship between the variables ni adalah one of the assumption to be proceed before we can do the regression analysis. So means that before kita nak proceed dengan regression, first step kena tengok dulu whether your independent variable ni, your dependent and independent variable having the correlation or not. Kalau tak ada correlation, no point kita proceed dengan regression. So dia punya assumption will not fulfill. So kena check dulu untuk correlation. So, macam mana check correlation? Kena cari nilai R. Cari tengok nilai R dan juga we can using the test of the correlation. And then boleh juga kita gunakan scatter plot technique, which is we plot X and Y axis of the dependent variable and independent variable, and it clearly suggests whether there is a relationship between the two variables. Okay, if the data ataupun the points create the linear line on your scatter plot, so we can suggest that the two variables having relationship. So whether it is strong or weak or moderate, we can test using the correlation test. In regression analysis, the dependent variable must be measured on a continuous scale. Okay, why? Y must be continuous scale. Okay, so you punya Y tu cannot be cannot be qualitative variable. Okay, should be continuous scale. Tapi untuk X boleh. Your X can be dipanggil boleh jadi dummy variable. Your X, let's say gender kan. So gender boleh jadi X lah. Kalau Y tak boleh jadi Y. Your gender cannot be Y. Gender can be X. Sebab apa? Y kena should be continuous scale. Kalau your Y adalah dichotomous ataupun nominal variable, kita boleh proceed bukan linear regression lah. Maybe dia akan jadi logistic regression. It can be multiple logistic regression. Okay. Later in maybe part 6 you akan belajar lah logistic regression. Okay, so the uses of regression. The regression analysis is helpful in developing equation. Okay, regression model provide the scientist with a powerful tool allowing prediction about past, present or future event to be made with information about past or present event. Okay, so using the regression analysis, we can develop the equation. Kalau linear regression, kalau simple linear regression, contohnya apa yang maybe you boleh ingat lagi, recall back that you have learned in diploma, y equal to a plus bx, right? So from that is the equation. Daripada equation that we have, that the equation yang we create tadi, kita kena test dulu whether this equation is valid or not. So you kena check all the assumption first, kan? So since let's say your model, regression model tadi ataupun regression equation tadi valid, so we can use that equation untuk predict about the past. Boleh nak buat prediction for future ataupun untuk present. Okay, for example, regression analysis used to describe the effect of income on education. So kita boleh tengok you punya Y adalah income and education will be X. Okay, so daripada situ kita boleh tengok bila education, maybe education you tinggi, so income you will be increase or not. So and then bila kita ada data, kita ada value X, kita boleh predict Y. Okay, Y untuk dipredict. Kita tak boleh predict X. X data yang ada, we can predict about Y. So we can predict income in this case lah contohnya. If we have the education level of a person. Okay, itu adalah example untuk regression analysis when we have create the model for regression. Okay, so untuk regression analysis macam tadi we will create the model ataupun we create the equation. So dalam equation tu akan ada parameter. Okay, by using the regression method, the parameter estimation can be solved. Kita kena kena estimate the parameter first. Let's say tadi y equal to beta naught plus beta 1x, so the parameter will be beta naught and beta 1, right? Okay, so we can estimate the beta naught and beta 1. So the parameter can be estimated by using the ordinary least square method, maximum likelihood method, and method of moment. Okay, we have these three method untuk calculate the ataupun untuk estimate the parameter of regression. But usually for this chapter 1 for degree level ni you will learn only ordinary least square method. Okay, ordinary least square method OLS yang biasa kita gunakan untuk estimate beta naught, beta 1, beta 2 and so on. So later I will show you how to prove the proving using of the OLS to estimate to come out with the formula of parameter estimate beta naught and beta 1 and so on. Okay, for prediction and estimation, many application of research involve prediction of the response variable. Okay, kita nak predict Y, like I said just now. For example, we predict the sales of a specific promotion. This prediction may be helpful in planning sales. Okay, so rather than that, kita daripada parameter kita boleh estimate the parameter, and we also can doing the prediction of response variable. Okay, next, the regression model may be used for control purposes. When a regression equation is used for control purpose, it is important that the variable be related in a causal manner. The existence of the statistical relation between y and x does not imply in any way that y depends causally on x. We also can use the regression model untuk create the ataupun to use for the control purposes. But for this subject kita tak fokus on this control part, hanya untuk parameter estimation dan juga prediction sahaja. So this is some of the example application of the regression analysis. The first one, for example, to determine the volume of sales based on expenditure spent for advertising, promotion, and sales incentive. So from here, y we can from these sentences we can determine the y adalah volume of sales, and x we have 3x here, expenditure, promotion dan juga sales incentive. We can predict the y based on all these x. Okay. Yang kedua, to predict the demand for the certain commodity based on the price and the price of other commodities. So y adalah demand. Sebab kita nak predict demand. So y adalah demand dan juga x adalah price of the commodity, the other commodities. Yang ketiga, to predict the price of house based on size, location, number of bathroom dan juga number of bedroom. So we have several x here, and y and price of house adalah our y. Okay, so this part adalah overview steps in regression analysis. Untuk chapter 1 ni, dalam your textbook pun adalah chapter 1 under topic linear regression with one predictor variable. So this figure ada dalam your textbook dekat page 14. Okay, so I will briefly explain about the process of the regression analysis secara ringkas. Okay, so first of all, once we having the collecting the data kan, data dah ada. Let's say sekarang data dah ada, dah collect data. So sebelum tu, but before that mestilah you kena adalah cara nak collect data, kena ada buat sampling kan, kena ada data collection method and so on. Okay, so when we have the data, we need first of all explore the data analysis first. What type of analysis that can we do with this data contohnya. So, untuk nak gunakan regression analysis, first of all, we develop once we determine that this data suitable for regression analysis. So, we develop one or more tentative regression model. Sama ada nak guna linear model ke, ataupun nak gunakan quadratic, ataupun nak gunakan polynomial model. So, kita develop dulu one or more regression model. And then, is one or more of the regression model suitable for the data at hand? So, suitable ke tidak? So, we need to check. Check all the assumption. Okay, setiap regression model, kita ada assumption, certain assumption. So, we check dulu the assumption. Kalau all the assumption is fulfilled, baru kita boleh proceed kepada yes. Okay, kalau tak, kena revise the regression model and check baliklah dia punya assumption. Okay, if yes, we identify the most suitable model. Okay, kita boleh buat selection model. Okay, nanti in this chapter belakang-belakang nanti akan ada selection model. You will learn how to you will learn the method how to select the model. Kita boleh gunakan R-square, boleh gunakan ada beberapa cara lagi lah selain R-square. R-square the common one, but we have another some of the other method to select the suitable model. And then once we have the most suitable model, so we make the inference and basis of the regression model. So boleh check lah, nak check significance, nak check all the beta tu significant ke tidak, nak check correlation and so on. Okay, so after that barulah you boleh proceed dengan the further regression analysis. Okay, so I masuk terus kepada assumption for model building. Okay, so assumption nak buat assumption of the regression analysis. Before we proceed with the regression analysis, so this part you need to fulfill first. Sebelum you nak check untuk significance semua sekali tu, kena check dulu assumption. So assumption of the regression analysis is based on the error ataupun residual. So, kena check untuk residual. Residual yang perlu independent and so on. Satu. So, first of all, you kena tahu dulu how to find the residual ataupun error of the regression data. So, EI equal to YI minus Y hat means that EI adalah notation untuk residual ataupun error. YI adalah observation. Y hat adalah predicted variable. Okay. So, untuk nak kira residual, kena create dulu regression equation. Okay, kena create dulu regression equation. Then we will use that regression equation untuk nak estimate Y hat, kan, predicted variable. Okay, so once we have the residual kan, kalau data you ada 20, residual akan ada 20 lah, kan. Okay, so kena check the residual. The assumption is the residual should be the error ataupun residual ataupun error term should be random and independent. So macam mana nak check for the independency? Adalah using the scatter plot, kan? You scatter plot of residual versus X, ataupun boleh juga kita tengok residual versus predicted. So if the I just briefly explain. Nanti next chapter akan ada lagi lah details about this. So actually, but actually you have familiar with this assumption using diploma level dulu. So I akan buat briefly revision sikit lah kan, supaya you ingat balik a little bit about the assumption. So nak check independence, kita boleh check gunakan scatter plot, residual versus X, ataupun residual versus Y hat. Okay, so if the mostly of the points are scattered randomly, so maksudnya tak nampak pattern, no pattern at all, so we can conclude that the residual are independent. Okay, if the point create any pattern, whether it is mencapah ataupun membentuk kuadratik, so we can conclude that the residual are not independent, so the assumption is not fulfilled. Okay, yang kedua, the error term have the mean 0 and the variance is sigma square. So kita boleh kira value of sigma square. So sigma square should be the value of MSE lah, MSE. Okay, so the mean should be 0, the mean of error should be 0, and the variance of error should be sigma square. We can calculate the value of sigma square using MSE. So the mean of residual should be 0. Bila you total up, bahagi, you akan dapat mean of the residual 0. Okay, the error term, and next the error term all have the same variance, the constant variance. Setiap satu error term adalah value of sigma square, and the error term should have the same variance ataupun dinamakan constant variance ataupun homoscedasticity. So macam mana nak check for homoscedasticity? Sama juga sebenarnya with independent tadi, kita boleh plot the scatter plot residual versus predicted. If there is the point scattered randomly around 0, so we can say that the residual are homoscedasticity. Ataupun boleh juga kita gunakan test of Brown-Forsyth. So I believe that you pernah dengar nama BF, Brown-Forsyth. So nanti next chapter you will face again this method of Brown-Forsyth. Okay, so dia punya method agak panjang, so you need to remember the step. Okay, so if you can make revision by your own first about the Brown-Forsyth, it will be your advantage nanti bila I masuk chapter Brown-Forsyth nanti. And then the error term are identically, independently and normally distributed. So macam mana nak check untuk normally distributed? We can use the normal probability plot. Okay, so we go to the simple linear regression model. Kita masuk terus untuk simple linear regression model. So untuk simple linear regression model, it will involve the single regressor X that has a relationship with a response variable Y that is a straight line. Okay, so if X dengan Y dia punya relationship are linear, so in the scatter plot you akan dapat straight line. So the simple linear regression model can be stated as follows. So this is the the regression equation of the simple linear regression. We have only one X. So it will be yi equal to beta naught plus beta 1 xi plus epsilon I. Epsilon ni adalah error term. Error term ni yang should be fulfill all the assumption tadi. Beta naught and beta 1 adalah parameter. Beta naught adalah y-intercept and beta 1 adalah slope. Okay. Alright. So epsilon tadi tu adalah random error with mean 0 and variance sigma square. Okay, so ini adalah illustration of the regression equation yang saya cakap tadi. Ini adalah simple regression equation yang adalah straight line kan. So how to determine the regression coefficient beta naught and beta 1? So we will use the OLS method tadi untuk estimate the parameter OLS, ordinary least square method, untuk estimate the parameter beta naught and beta 1. Okay, kata the least square method tadi OLS adalah statistical method that is used to determine the line of best fit. Kita nak create the regression equation tadi gunakan OLS method such that the deviation of the actual values and predicted values is minimum. So dia punya deviation di antara y dengan y hat adalah minimum. Bila kita gunakan OLS method, why we use the OLS method? Sebab bila kita gunakan OLS method, the deviation between the y and y hat tu akan jadi minimum. So because of that, kita punya error will be less. Bila error less, model lagi baguslah. Kan? Because of that, kita gunakan OLS method. Okay, itu adalah definition untuk OLS method lah. Kenapa kita gunakan this method untuk estimate the parameter. But actually, we also have the other method, which is MLE dan juga MUM. So, maybe in the next level, maybe master ke, you akan belajar lah the other method ni. Okay, so beta naught adalah y-intercept, beta 1 adalah slope of the regression line. So you need to know how to interpret the value of beta naught and beta 1. You need to memorize the interpretation of that. Okay, so beta naught adalah y-intercept, beta 1 adalah slope. Slope ni adalah indicate that the changes in the mean of y for every unit increases in x, because of we know that y adalah y depends on x. So in every unit increase in x, y will also increase, okay, by beta 1 value. Okay, so for example, ini example kita simple linear regression. Y adalah income, sebab income ni berada di y axis kan. Y adalah income dan experience adalah x. Okay, so income depends pada year of experience. Okay. So when we have the data, kita dah data lah, data before we come up with this regression equation, we need the data first, baru boleh nak create this equation. Okay, bila ada data we regress y and x, so keluarlah value. Contohnya kat sini beta naught 15, beta 1 0.3. So you need to know how to interpret this value. So here beta 1, the interpretation of beta 1 is kat bawah ni. For every 1 year increase in experience of working, which is your x, in every 1 unit increase in x, the y will also increase by berapa value of beta 1. Kat sini value beta 1 is 0.3. Kenapa kat sini RM300? Sebab di sini unitnya income adalah 1000. So 0.3 kena multiply by 1000. Okay, remember untuk interpretation of the beta 1 and beta naught ni, interpretation of the parameter, unit kena letak betul-betul. Kat sini unit untuk x adalah year of experience. So kena letak for every 1 year increase. In x, the y income will increase. Kat sini will increase or decrease. Ada dua, sama ada decrease ataupun increase, depends pada the sign of beta 1. Kalau beta 1 U negative, kat sini will be decrease. Okay, kalau kat sini, contoh di sini beta 1 is positive, sebab itulah ianya increase. Increase by RM300. Kena letak RM. Unit kena letak betul-betul. if you want to get the full mark. Okay, so in ataupun kalau you nak buat in your own words, tapi maksud yang sama pun boleh. Contohnya, let's say you katakan, when the year of experience is increased by 1 year, the income will also increase by 300 ringgit pun boleh. Okay, so tadi adalah interpretation untuk parameter. So this part adalah the formula to get the beta naught and beta 1, if you still remember. So this is for the formula to get beta naught, which is y bar minus beta 1 x beta 1 hat x bar. So in order to find the beta naught, kena cari dulu beta 1. So macam mana cari beta 1? This is the formula, sxy over sxx. Formula kena hafal. Apa dia xxy? Which is the summation of xy. Macam mana nak cari summation of xy? Kan kita ada data x, kita ada data y, kita ada kolom x, ada kolom y. Summation of xy ni adalah total of bila you multiply x dengan y. Okay, let's say we have the two column, kan? Kolom x dengan kolom y. So summation xy ni adalah total of when you multiply x dengan y. So before this, kalau you buat secara manually, you need to multiply, you need to create another column untuk dapatkan multiplication of x dengan y. So total of multiplication of x dengan y tu, you akan dapat summation of xy. Okay, and then summation x adalah total of x column, summation y adalah total of y column, n adalah number of observation, berapa banyak you punya data ada, itu adalah n sample size, kan. So sxy pula yang nak letak dekat bawah ni adalah summation of x square. You need to square the x value first, baru you total up. Bukannya you totalkan x, you square. Beza, salah. You kena squarekan x dulu, baru you total up. Okay. So this part barulah summation of x square. Totalkan x baru square. This part total squarekan x baru total. Okay. So first cari dulu beta 1. Once we have the value of beta 1, replace beta 1 in this formula untuk dapatkan beta naught. Okay. So y bar adalah mean untuk y, x bar adalah mean untuk x. So lastly you akan dapat equation. It will be y hat equal to beta naught hat plus beta 1 hat x. That is your regression equation. Okay. Okay. Okay, and then you kena aware that bila you tulis regression equation, y hat tu kena ada dia punya topi tu. Y hat means that you dah we have the estimated regression line ataupun regression equation for that data. So kena ada y hat equal to beta naught hat. Kalau ada value, letak value plus beta 1 hat. Ada value untuk beta 1 sebab kita estimate, multiply x. Okay, so let's see the contoh. Let's see the example for this data. A real estate agent wishes to examine the relationship between the selling price of home and its size. A random sample of 10 houses is selected. Y adalah house price in unit 1000 RM. Independent variable adalah home size in unit square feet. So we have all the data. So from the data, we can answer all these questions. Okay, first of all, state the purpose of the OLS method. Okay, so like I said before this lah, OLS method adalah, kenapa kita gunakan OLS method? To because of when we use OLS method, it used to estimate the parameter so that the sum of square error is minimum. Okay, error untuk kita akan dapat error yang paling minimum, which is the deviation between y and y hat will be minimum, so error also will be less. Okay, soalan yang kedua, use the OLS method to estimate the beta 1 and beta 0. Then state the estimated regression function. So you kena ada last kali kena ada regression equation. So using the formula of beta 0 dan beta 1 tadi formula, so you can calculate. So nanti you cuba try dapatkan summation of y square, you will get this value, summation of y, summation of x square, summation of x, and summation of xy, also n. Okay, you need to have all this value first untuk you kira, untuk you apply the formula of beta 1 and beta 0. Okay. Okay, untuk dapatkan all this value of summation ni, summation x, y and so on, you also can use the calculator, right? So still remember how to use the calculator. So it is an advantage for you if you can use the calculator untuk dapatkan value of y. And then instead of that, actually you also boleh dapatkan, boleh check lah, double check nak tengok value beta 1 dan beta 0 you betul ke tidak. You have learned before this in diploma. Tapi walaupun using the calculator you will straightly dapat value beta 1 and beta 0, but still you need to list down all the value of summation ni, all the summation untuk dapatkan full mark, and then baru you boleh gunakan formula untuk dapatkan value beta 1 dan beta 0. So kena ingat balik lah macam mana nak guna calculator, scientific calculator. Okay, so kena masuk dululah, kena masuk regression dulu, kena masuk mode regression, then masuk mode linear, and then nak masukkan data macam mana. Okay, just masukkan data. Data you, let's say tadi data yang pertama adalah, jauhnya. Okay, kena masukkan dulu x, y. Okay, 1400, 245. Okay, dan tekan equal. So, you masukkan satu value. Okay. And then, you kena buat untuk semua masukkan all the observation, 10 observation. Okay, tadi saya ulang balik. You kena masuk dalam mode regression, pilih linear, dan untuk key in data, masukkan x dulu, y, dan tekan M+. Okay, tekan M+, so you dah masukkan satu data. So repeat again until you masukkan all the 10 observation. So actually you dah biasa dah buat ni kan, so tak ada masalah I rasa. And then kalau untuk nak tengokkan all the estimation, kena shift dan ambil satu, which is the sum. So you boleh tekan dan equal untuk dapatkan all the value of summation tadi. Okay, you should try this. Mesti kena try yang ni supaya you boleh apply nanti. Okay, kena try dapatkan all the summation and then apply the formula. Formula kena ingat. Okay, you also can check the value of beta 0 and beta 1 after you calculate using the formula lah. You boleh double check using calculator. Beta 1 and beta 0 ada value dia kan. Okay, kena shift 2, betul tak? And then you press the arrow ke kanan, and then you akan adalah value A dan B kat situ. Okay, so A adalah value beta 0, B adalah value beta 1. You boleh double check whether your regression equation ni betul ke tidak. But still, you kena list down all the value of summation and then apply the formula to get the value of beta 0 and beta 1. And last kali should be kena ada kat sini, saya tertinggal. Last kali kena ada equation. Y hat equal to beta 0 is 98.193 plus 0.1098x. Kena ada equation. Last kali. Okay, the next question is interpret the slope of the regression line. Okay, you need to interpret the slope. So, the value tadi, slope-nya adalah 0.1098 and then dia punya unit untuk Y adalah in thousand. Right, in thousand, and unit untuk X adalah square feet. So, how you interpret the value of 0.1098? So, it should be for every 1 unit increase in square feet ataupun for every 1 square feet, for every 1 unit increase in square feet, the house price will increase. Kenapa increase? Sebab value of beta-naught adalah positive. Will increase by, should be berapa tu? Should be 109.80. RM 109.80. Tapi you nak tulis dalam bentuk macam ni pun boleh. Tapi make sure kena ada unit lah kat belakang tu. Okay. So, boleh juga dikatakan when the size of house increase by 1 square feet, the house price will also increase by RM 109.80. Okay, that is the interpretation untuk beta 1. Okay, the last kali kat sini dia nak you plot the estimated regression function and the data. Plot the estimated regression function. Function yang you dah ada tadi tu yang you dah create tadi, function kena plotkan dalam scatter plot. Okay, first of all, bukan simply you gariskan you dah buat line ni, bukan. You kena lukis betul-betul according to your regression line yang you dah ada. Okay, so yang biru, point biru ni adalah you punya data. Okay, data ni ambil daripada mana? Daripada yang awal-awal tadi kan ada 10 data kan, ada X, ada Y. So, you plot macam biasa. Plot yang biru ni macam biasa, scatter plot. And then, how you draw the regression line here. Kan, you ada tadi value of beta naught and beta 1. So, how you can do that? Okay, so nak buat regression line, nak buat straight line, kan, remember you kena ada 2 point, betul tak? You kena ada 2 point. So, create the 2 point dulu, and then bila ada 2 point, you boleh gariskan. So, I rasa biasanya lah dulu waktu you belajar dulu kan, you kena create bila X 0, Y akan jadi berapa, bila Y 0, X akan jadi berapa. So, bila you dah ada 2 point tu, you boleh plotkan. Ataupun you boleh create the line tadi tu. Ataupun satu lagi cara adalah sebenarnya you kena dapatkan point, setiap point. Tadi ada 10 data, so you kena ada 10 lagi data untuk Y hat pula. Macam dapatkan Y hat tu, you kena replace all the X dalam equation Y hat equal to beta naught plus beta 1 X yang you dapat tadi, and then you will have the column of Y hat sahaja. So daripada situ yang you dah kira satu-satu Y hat tadi tu, so you plotkan di atas graf yang sama, and then it will create the straight line. Ada dua cara lah, sama ada you nak kena create satu-satu, you nak kena calculate satu-satu Y hat, ada 10 data, then you plot, ataupun you create 2 point sahaja untuk you draw the straight line atas paksi yang sama. Y dekat sini adalah house price, X dekat sini adalah home size. And then remember, bila you nak lukis scatter diagram, kena ada tajuk dan kena ada label of y-axis dan x-axis. Kat sini ada salah sikit sebab tak ada label of y-axis. Should be kena ada kat sini house price, kena tulis kat sini house price, kena tulis di sini adalah home size. And then ditanya lagi soalan dia, does a linear regression function appear to give a good fit here? Bila you dah draw the straight line using the two point yang you ada, ataupun bila you calculate all the y hat. Okay, bila dah draw the straight line yang you ada tu, you observe sama ada it will give a good fit or not. Macam mana you tengok? Okay, kalau straight line you ni berada di antara plot scatter plot yang you draw sebelum itu. So kalau dia berada di tengah-tengah dia, so we can say that the regression function tadi give a good fit. Okay, so for this example, the linear regression function that we draw appear to give a good fit here. Okay, salah sikit kat bawah tu dia tulis not appear to give a good fit. So actually it is appear to give a good fit since the regression line that we draw berada di lingkungan scatter points dalam kita punya rajah tersebut. Okay, so for this session, that's all for this session. I will give a task for you that you need to submit today. If you have any other question, you can ask in WhatsApp or Google Classroom as well.